Okay, welcome to the special benchmarking meeting, which is a deep dive on the NODE-EIS workload being presented by, I guess, Udom from Intel. It's a new workload that we're looking at in the benchmark group as an option to cover some of the use cases that we want to cover. So Udom, I'll let you take it from there.
Okay, thank you. Is that Wayne or?
Say what?
Uttam, it's actually Michael talking, and he coordinates the monthly Node.js meetings, and he set up the special meeting for us.
Okay, sure.
And there's also Wayne on the call.
Okay, so this is, I'm just going to talk about the internals of NODE-DC-EIS workload, or the benchmark we have created at Intel. This diagram, I'm just going to drive into it. The diagram you see here is a very typical Node application, what we know looking at, and we kind of learn as we looked at many usages. So you always have a Node.js based server. There is a MongoDB database at the back end, and the client could be either AngularJS, which is disconnected from the Node server, or it could be inside us in the Node.js application itself, like a rendering of the web pages and things like that. But this is a very typical way the application looks like. Pardon my the error here. It says the Node-ELS. As I said, I did not get a chance to prepare the slides because I just came back from vacation like a day ago, a couple of days ago. So. But this is actually NODE-DC-EIS internals. So as it says, it has a database MongoDB at the backend, and it has a various collections like employees. Employee have addresses. Employee have health records. Employee have family records and compensation and photo. So this is, think about employee directory in a company. So that kind of application we try to mimic. And all these collections are linked with employee ID. And we use Mongo's schemas to create those collections, create those schemas, and they linked with the employee ID across all the collections. So when we started, this is what we started with our vision, what this application should do. So what we know that we wanted to keep the employee directory as a central focus, but we wanted to represent in multiple ways. We wanted to create a monolithic application, like most of the Node applications are. So all these are done in one or two controller files, or maybe one, server.js. We also wanted to represent the similar environment using the cluster mode. What happens if you run this in a cluster mode? The same application. So your database kind of remains the same. No changes required there, but you just start the multiple processes as many cores you have on the server. And then also, we want to divide the same application again on the functional level. So there's an employee service, then there's a health service, there's a photo service, and there is a compensation service, and so forth. In that case, you can keep the database same, or you can actually separate out the database also. But in this case, I think we have the same database at the back end. So that means we can clearly see what happens if you deploy a Node application in certain one of these scenarios. What could be the performance, whether monolithic, cluster, and the microservices mode. And then people can get kind of really understand what would the benefit, which is the best way for their application to deploy, and we should give you the best performance on whatever available resources they have. And for NODE-EIS, what we did, we developed the client in Python using its green pool threading mechanism, so we can start a very lot of concurrent connections, and everything can be done from the command line. So as you can see this, the database remains the same, the client remains the same, the application itself, the functionality remains the same, it's just then deployed in different ways. Okay, any questions so far?
Seems clear to me.
Okay, and one more point here is, so the diagram is shows we can now add more scenarios to do the same thing. Here in this case, we can add, let's say, server-side rendering. So we can add another mode where we create the web pages from the server side, and we can extend that functionality or the deployment of the application. Okay, so here I will just talk a little bit about the run spec. What we did, we actually took a reference from how the spec benchmarks are structured. Most of those workloads, the benchmarks have run spec as the front-end utility, which kind of sets a lot of parameters and it executes the program. And we try to see whether we can learn something from that, because it has been proven for many years or many generations of the spec CPU benchmarks. So we kind of learned from there, and we built our own runspec.py with many parameters. So initially, what we wanted to do was, when the database starts, we wanted to see, is it possible that the client says, hey, I want to populate database with 1 million records. And then Python runspec.py will send a request with all the required parameters, number of records, how they should be distributed, and things like that. And I'll go more into detail about each of those options. But that was the overall idea, what type of output we want to generate, how much is the concurrency could be, to show how many parallel connections can be from client to server, and debug and a lot of other options. Okay. So these are a little bit of description. So there's a config file. You have a -f config where you can specify all these parameters into a config file on the client side. So the client can read those config parameters and then make the calls to the server. At the same time, you can override those options from the command line. You can override the number of requests. You can override the concurrency. You can override the ratio. Let me talk a little bit about these three ratio. What we mean by that. So as I said, we wanted to mimic the employee directory in a company. So you have employee names, you have employee phone numbers, you have employee addresses with some zip code. So what we really want to do was, we want to distribute those employee records, the name, certain way. For example, employee have a last name. Maybe there is a John Doe. Now Doe is let's say last name, and then we wanted to create, let's say, 10,000 records. We want to distribute that different last name with certain percentages. So anytime we make a query, we at least get certain number of records back. So if you request for, give me records with last name is Doe, and we should get maybe 10% of those records. So, and there could be another one. Let's say my name Uttam Pawar. If I inquire with last name equal to Pawar, I will get another 10%. So every time the network load kind of remains the same, approximately. Again, it all depends on this number of parameters. But the idea was to, whenever any query we make, we get a certain amount of load back, the data back. So that's the name URL ratio. It says 10%, 20%. Again, that is in the config file. And the same thing is true with the zip code. So if you distribute the employees across multiple zip codes, we want to make sure that for every zip code we request, we should get certain amount of data. So that means it is not lopsided when one zip code has 100 records and another zip code has 0 records and another one has 10,000 records and things like that. So we wanted to make sure all the URLs we are hitting, we are getting decent amount of data back. Okay. The DB count is how many total number of records we want to populate in your database. We talked about the name, we talked about zip ratio. The order is how we want to issue the requests. Then should they be sequential? They should be in shuffled way, in a sense. They can be of different type of request mixing. So that's just a brief information. Okay, so are there any questions on this? I think this is probably most, two more things I want to talk about, the ramp up and ramp down. what this says is when the server starts, when the database is populated, and you say, hey, I want to mimic 1,000 requests. What ramp up and ramp down flag does, it says that I want to run some number of requests. I want to issue some number of requests before we actually start the measuring time for the performance. So that the server has started and we made some request and it has processed some of the requests. So it has processed some of the callbacks, and hopefully a lot of them got into cached. And hopefully the server is in kind of stable state. And then it could be 100 requests, 200 requests. By default, I think we have 200 requests. So 100 requests for the ramp up and 100 requests for the ramp down. So so that we can avoid those initial peaks or the valleys, and kind of let the server finish properly at the end. And after the 100 requests are processed, then actually start the measuring time of remaining 1,000 requests. So total requests will be issued will be around 1,200. So 1,000 is what we want to measure, and 100 ramp up and 100 ramp down. So total 1,200 requests will be issued. But after first 100 are done, we start the measuring time. And only for the 1,000 requests, we'll get this request per second metrics. And that's the idea with those two variables.
So sometime ramp up and ramp down is by time. Did you think about that at all?
We actually thought about it. We just have not implemented it. So we want to, right now it is all request, number of requests, but we definitely want to add a scenario to do a time-based runs. And we want to run for, yeah. So we actually we have thought about it.
Okay.
And hopefully now that we have kind of, it's out there in open source, hopefully we can kind of work together to see what else we can do about it.
Okay, thanks.
So this is, I think, major crust of the client. And then we can go into, so these are some of the numbers we collected to see what are the different ways the performance we get. Again, just pardon this Node.js. I apologize for that. So there is it creates the latency graphs. So you can see on the left side, we have a latency graph for the monolithic, which is a orange color, then microservices, which is a yellowish color, and the cluster mode, which is a green color. And there's the corresponding throughput on the right side. And then now, without actually for the end user, in general for the community, people can run this workload in various fashion and kind of get a general idea what would be the best for their application before even you could in fact deploy or even develop an application. Well, that's it. That's what I have. Again, I did not get any time to prepare. So this is just my old slides from way back. I don't know what else you can, what else you would like to know, and so I can talk more about it. So things are, let me go to a little bit of in terms of the routing mechanism. So as you see, there are 5 or 6 collections. And you can imagine we have get me employees get all employees, get employee by ID, get employee by last name, get employee by zip code. Then similarly, you can go other collections, get photo for an ID, for an employee with a particular ID, and so on and so forth. A lot of functionality, the queries we have assembled using async module internally. So let's say if you're looking for employee information by an ID, then you get an employee ID from the employee record and then go use the async module to receive or execute parallel requests. So you use async.parallel, and internally you call into the address.find, compensation.find, health.find, and so on and so forth. So we try to use all the modules which are most popular in our Node community, and try to see as much as JavaScript gets executed and not so much directly call the queries into database or serialize queries into database.
Yeah, I guess that is an interesting question, yeah, which I'm sure we can see by looking at that, what all modules are being used there, but it's a good point, trying to cover some of the key ones in the community.
Right. And again, we all are we are kind of at Intel, it's almost a year, but still we are kind of learning. We don't have a lot of Node.js or JavaScript programming expertise here, but try to do as much as possible. Try to looking at all these npm top module. So MongoDB is one. Another thing we learn over time is the Mongoose driver is not so much performance efficient. So right now we are working on adding another mode where we use only the MongoDB native client, so that we can see the clearly difference between the Mongoose. The Mongoose gives you schema, which is very good, but maybe performance is not so great compared to MongoDB native client. So we're trying to assess that and hopefully add that as another mode into the Node-DC.
Right, okay.
And as I talked about the server-side rendering, so initially we are just going to have a default template engine, maybe handlebar, but we can definitely go with what Walmart has, Electrode, I believe, or something like that. So we want to mimic that also. And so things are remain same, but this rendering and all the internals will change. But adding another case to it, not so much as a replacement, but adding another case to it. I don't know, that hopefully that will be useful for a lot of people looking into what different modules I should use. What are they typically give me best performance, best flexibility, and then decide to go on their development.
Yeah, if there's a way you could plug in different modules to do the same thing and then compare them, that would be interesting.
Yeah. So again, those are like, we have big wish list, and we hope that we will, once it gets more traction and getting more feedback from experts and our node benchmarking committee, we can kind of suggest and keep the list on the GitHub, and we and the whole community can work around it.
Right. So I guess the next step that I could see that'd be useful is like a proposed configuration, along with the the explanation of which of the sort of use cases it covers. Because that would be like a concrete. Okay, let's we know that in what we have is a single machine with 4 cores. So for Acme Air, we actually pin like the driver to 1 core, we pin the database to 1 core, and then we use 2 cores to run the actual benchmark. So if we had like a similar proposal to say, okay, let's set this up like this, it gives us, looking at our use cases, I think it's certainly, from the picture here, it looks like it's, will give us coverage on the REST service type use case.
That is true, yes.
So if we could come up with a configuration, then it covers that. Maybe there's others that would cover others as well, but that would be a starting point.
Yeah.
That would be something that then we could try out and, see if we can get running in the community benchmarking machine and possibly running on a nightly basis.
Sure. Yeah, so these 3 definitely could be a starting point. Again, monolithic and cluster, we have just one mode, and that changes depending on what the configuration parameter is. For example, config file has a CPU count equal to -1. That means it will determine at the runtime how many cores available, and it will start that many worker processes. But you can say, hey, just run 1, and it will be like a monolithic application there.
Right. So that's the case where we could probably run 1 or 2. Like I guess,
right.
If we did the same model of we use 1 core for the database, 1 core for the client, and then the 2 cores for the app.
Right.
We could run, I guess, like the one monolithic or cluster with 2, which isn't a huge number, but.
Right. And we have tried this, the cluster one on more than 56 cores, and it just scales very well. It consumes almost more than 90% of the CPU, all the cores. So it really scales, and that really shines and show the power of the clustering and using all the cores available.
Does it, in terms of clustering, is that something you built into the app, into the benchmark itself, or is that using like the built-in node clustering?
No, we use a node clustering. So we wanted to do everything possible just from the node, nothing custom.
Right. Okay.
Because we want to, at the end of the day, we want to improve those modules, especially starting with the node core and then going to the most popular modules.
Right. Yeah, makes sense.
And if you want, I mean, the internals, is already code is out there. So internals are, as I said, there are very few APIs, get, and of course it does the post and delete operations also. So it is not just get. One thing we did notice that when you kind of do multiple different types of operation, like you do issue some get request, and then you do some post request and some delete request, suddenly the performance varies. And we are kind of investigating. That's one of the line we are saying why the performance varies so much. Um, if you just do get, everything is great. But if you just add maybe 1% of post request and 1% delete request, performance goes down. So what's happening? Is this something happening in the node event queue or query level or at the client level? And it kind of gives a different view into your overall execution, because that's a typical way any application would work, not just populate once and then read from the database.
Right. Okay. While we continue to take questions from people on the call itself, there are 11 viewers of on the YouTube channel. So if any of you have any questions, if you want to post them to the Node-Dev IRC channel, I can pass them on. Also,
you mean pass the presentation on, or?
Well, no. Basically, there's people watching through YouTube. So if they post their questions in IRC, I will, basically add them.
Just read, okay.
So that we can answer them here. I guess the other way people could post questions who are listening, if they're interesting, is into the issue itself that was open for the talk. We'll check that place as well. So
okay.
Maybe give people a few minutes there to answer it, to see if there's any questions. Just navigating to the issue itself just to see if anybody's posting anything there. Okay, I don't see any questions there yet. Just double checking back to free node or node dev as well. I don't see any questions there either, but we should probably wait a few more minutes just in case. So, but yeah, I mean, if you guys can put together like the proposal of here's a configuration that would run on the machine we have, we can, start to understand.
Okay. Okay.
And then sort of also look at that use cases and say, okay, yeah, this particular configuration fills in this use case, because that's our overall goal, is to fill in that coverage.
Yeah, and I think on our GitHub Node.js GitHub page, we have a great list already. We have talked over year what are different use cases, and we'll see you kind of check marks saying, hey, this kind of addresses that one. Yeah.
Right, exactly. So yeah, if you start to fill that, basically say this configuration will cover this use case, and then here's how to set it up.
Yes.
That's the way to go.
Yeah, Uttam, I sent the link to the use case page from the benchmarking GitHub.
Yeah, and there's actually another one which is case coverage. Maybe that is the right one? I just try.
Yeah. So they have different coverages, like microservice-based applications, which we cover. Then they have another section for generating and serving dynamic web page content.
Yeah, I have that link. Yeah.
Yeah, and if we have something that's missing as well, then we should work on adding it into there, right? So.
Yes. Yeah.
So I think, like the microservices-based applications one probably describes, I'm sure in the words it should say REST in there somewhere. So like that would be an area where, okay, this configuration of the NODE-DC-EIS will cover, at least give us some coverage for microservices-based things.
Mm-hmm. Yes. Yeah,
if there's other configurations, we can sort of, cover the other areas too.
Yeah, as I said, we are, right now actively working on creating this server-side rendering use case. So
Right.
to just send you the HTML document. So that will be, you'll see that soon, probably in a few weeks.
Okay. Because yeah, that might be another one that we can use for that particular use case, right?
Yes.
Okay, so I'm just going to double check both the issue again to see if there's any questions from people watching. Let's see, I don't see any questions there. I'll double check Node Dev. I don't see any questions there either. So I guess unless there's more questions on the people who are actually in the call itself, or if there's anything else we want to discuss or present today, maybe we'll call the end of the meeting.
Okay, I think I'm done with the presentation and definitely open for questions either now or even on the on our GitHub or so anywhere. That's fine.
Yeah.
And we will definitely work on the proposal and
Yep.
kind of go from there. Yeah.
Okay, sounds good. Thanks for everybody who joined the call and who was on the watched in the YouTube. We'll talk with everybody later. Thanks.
Okay. Thank you. Thanks for your time.
Yeah.
Thank
Bye.
you. Thanks.